So we have the coordinate system in section 2.1. Now, what is coordinate system? Have you seen what it looks like? And what do we use coordinate system for? What is the use of this coordinate system? Okay, slope, graphing equation, anything else? Like, what does it mean by having a coordinate system? Like, how can you use coordinate system? Now, in general, okay, so we use a coordinate system to locate the position of a point. Like, if we have a point, then we can locate that point with the help of coordinate system. Okay, we can find the position of a point, and yes, we can just make a graph. So for different equation, we can graph different equation in the coordinate system. Now, what do we have in the coordinate system? So in our coordinate system, so what do we find? So we find two lines, right? And what do we call those two lines? So we have the vertical line in the coordinate system. And what do we call that vertical line in the coordinate system? Y-axis, right? So this is the y-axis. Okay, we have our vertical line, y-axis. And what do we call the horizontal line? So this is our x-axis. Okay. Now, what about the point where these two lines intersect each other? So what do we call this point? So we have this point, okay? So we have this point here. So our x-axis is the horizontal line, y-axis is the vertical line, and these two, horizontal line and vertical line, intersect at this point. Okay, let me call this point is O. And what do we call this point? O. Origin. That's the origin, right? Okay. Now, what about the angle between these two lines? So, what angle, in what angle these two lines intersect? 90 degree, right? So, if we have a coordinate system, then the horizontal line and vertical line, they intersect at a point. That point is the origin, and they intersect at 90 degrees. So, here, the angle between these two horizontal line and vertical line. So, this angle. So this angle is always 90 degree. Okay, if we are talking about coordinate system, so we have the x-axis, which is the horizontal line. We have y-axis, which is the vertical line. We have origin, that is the point where these two horizontal line and vertical line intersect. Okay, and the angle made by these two lines, vertical line and horizontal line, is always, it has to be 90 degree. Okay, so this is our coordinate system, and we locate the position of different point in this coordinate system. Okay, now, so in a coordinate system, now how do we, okay, now on the right side of the x-axis from origin, okay, now what kind of number do we have on the right side of this origin along x-axis? What kind of number do we have? Positive number, right? So on the right of origin along the x-axis, these are the positive number. Okay, and what about the on the left side of the origin along the horizontal axis? So what kind of number do we have on the left? We have the negative number, right? So here, let me redraw this one. So we have vertical line, that is y-axis. So this is our y-axis, this is our x-axis, this is our origin. So on the right of the x-axis is always positive number. So let's say this is 1, 2, 3, 4. On the left of origin along x-axis, this is negative number. Okay, so we have negative number on the left. So this, so negative 1, negative 2, negative 3, negative 4, and so on. Okay, now what about what kind of number do we find above the x-axis along y-axis? So what kind of number do we find along this part here? Positive numbers, right? So we have positive number. So we have positive 1, positive 2, positive 3. Okay, if we go below the x-axis along y-axis, we have negative number. So we have negative 1, negative 2, negative 3, and so on. Okay. Now, so what do we call this portion? So what do we call this portion? Only this portion. What do we call this portion? It's the first quadrant, right? Or the quadrant 1. So this is our first quadrant, okay? So this is our first quadrant. And in the first quadrant, okay, so our x-axis, along the x-axis we have positive number, and along the y-axis we have negative number, right? So this is our second quadrant, okay? So this is our third quadrant, and this is our fourth quadrant, okay? Now, what kind of points can we plot on the first quadrant? So what has to be what kind of point? So the point has to be positive, right? And how do we just write down the position of a point? What do we use to write down the position of a point? So okay, let me take a point here. So okay, so if I have a point, and let me call this point is this one. Now how do we write the position of this point? So what do we use to write down the position of this point? Is it an interval, or is it a order pair? So how do we write a point? So okay, now here, so we use order pair, and how do we write order pair is that? So we have parentheses, right? So let's take a first element of order pair. Let's call it x, and we have a second element called y, and you have parentheses close, okay? So this is our order pair. So every time if we are writing a point, then it has to be in a order pair form, okay? So you must have a parenthesis, okay? You must have a parenthesis, and the elements, so we have two elements, and these two elements has to be separated by comma, okay, and the parenthesis close. So this is the order pair, okay? And in this order pair, what do we call the first element? What do we call the first element? X coordinate, right? So our first element of every order pair is x coordinate. If we are talking about a point, okay, so do not get confused with this order pair, okay? So we did order pair, so here, so do not get confused this with order pair. Look, for example, let's consider we have an order pair 3 5. So this is an order pair, okay? And 3 5, it can also be a point, okay? Now if you have an order pair, what it means? So you have order pair 3 5, what does it mean? So it means that this is a set of number, okay? So let's talk about this order pair, okay? Sorry, let's talk about this interval, open interval, okay? If this is an interval, then this is a set of numbers, okay, which is greater than 3 and less than 5. So every number greater than 3 and less than 5 is in this interval, open interval, okay? But if we are talking about the order pair, this is a point, okay? This is a point on the Cartesian coordinate system, okay? And the first element of the order pair is the x coordinate, okay? And the second element is the y coordinate, okay? We will define what are these x coordinate and y coordinate are. So if we are talking about the interval, we are talking about the set of numbers, okay? But if we are talking about the order pair, it's just one point, okay? That is the position of a point. So here this 3 5 is just a single point in the Cartesian system, okay, coordinate system. But this 3 5 interval is the set of infinite numbers, okay? Now here we will focus on the order pair, okay? So we write order pair inside the parenthesis. First element is our x coordinate, second element is our y coordinate, okay? Now what is this x coordinate is? Now what is this x coordinate on the graph? So how do we find the x coordinate? I'm sorry?
On the x-axis?
Okay, so x coordinate is on the x-axis. Okay, what about the y coordinate? So how do we find the x coordinate and the y coordinate? Okay, now for this point, can you tell me what is x coordinate and y coordinate for this point?
2, 1.
So you, okay, so you said 2, 1 is the coordinate for this point. Now what is 2 here? And what is 1 for this point?
X1 and y1.
So x is 2, y is? Now what does that mean? What it tells about this point? Now you have a coordinate of a point is 2, 1. So the coordinate of a point is 2, 1. So we have 2, 1 as a coordinate of a point. Now what this coordinate tells us about the point? Now how do we locate a point with the help of this coordinate? So you have a coordinate, okay, you have the 2, 1 as a coordinate of any point. Now what information can you get from this coordinate 2, 1? So what this tells us about a point? How do we locate a point with the help of this 2, 1? Okay, 2 on the x-axis and 1 in the y-axis. Okay, close enough.
You start from the origin and move from there.
So every time we are starting from the origin, right? So we go horizontal how many distance? 2, and vertically up by how many distance? 1. Okay, so here, so if we have an order pair, then the first element, which is the x coordinate, this x coordinate tells us how far our point is from. So it tells about, okay, it tells the x coordinate, okay, it tells about a point, how far the point is from the y-axis. Okay, so we have a point. Okay, let me draw one more time. So here, so we have a coordinate system, and we need to plot a point 2, 1. We need to locate this point. Okay, so here the x coordinate is 2. Okay, it means the point is 2 unit distance, okay, from y-axis. So our y-axis is this vertical line, okay, x-axis is horizontal line. Now every time the x coordinate, it tells us how far a point is from y-axis, okay, or how far the point is along x-axis. So it's the same thing. So let's say we have 2 here and we have 1 here. Okay, so we have this point. Okay, what is the distance of this point from y-axis? Can you tell me the distance of this point from y-axis? So distance of this point from y-axis, that is 2, right? And 2 is our x coordinate or a y coordinate? X coordinate. So x coordinate tells us how far a point is from y-axis. Okay, now what is the y coordinate of the same point? So what is the y coordinate of the same point here? So y coordinate is 1, right? And what is the distance of this point from x-axis? So the distance of this point from x-axis is also 1. Y coordinate is also 1. It means y coordinate give us the distance of a point from x-axis. Okay, x coordinate give us the distance of a point from y-axis, and the y coordinate give us the distance of a point from x-axis. Okay, now let's try to plot a point for different points. Okay, let's consider we have point here. So if we have a point, let's say we have -1, -3. So this is a point. Now what can we say about the point? Now how far is this point from x-axis? Is it okay? Now what does it mean by negative? Distance can't be negative, right? Now what does it mean by having a negative in the front? So it's on the, is the point on below the x-axis or above the x-axis? Yeah, so if you have a point below the x-axis, we get negative y coordinate, right? So let's plot this point. So we have a -1 here, and we have negative 3 here. So this is the point with the coordinate negative 1, negative 3. Okay. So we have this point with a coordinate negative 1, negative 3. And this point is at a distance 3 from x-axis. Okay. So this distance. So here this distance is 3 and is below the x-axis. Okay. And the same point is at a distance 1. So at a distance 1, okay, from y-axis on the left. Okay. So if we go on the left, then y-axis or y coordinate is negative. Okay. And if we go down, the y coordinate is negative, right? So we have negative here, negative 1, negative 2, and this is negative 3. So we have negative 2 here, negative 3. So in general, so in the first quadrant, so if our x coordinate is positive, y coordinate is positive, then those points are in the first quadrant, right? So if we have a point, and if the point has x coordinate and y coordinate, both are positive, then those point lies in the first quadrant. Okay, so this is our first quadrant. In the second quadrant, okay, in the second quadrant, is the x coordinate positive or negative? So what will be the sign of x coordinate in the second quadrant? So let me take a point. Okay, let me take this point. Okay, so let me call this is 2. So what is the coordinate of this point 2? This point? So this is negative 2, negative 2, right? So what is the x coordinate? Is it positive or negative? Oh yeah, it's negative 2, positive 2. Thank you. So this is not negative 2 here because our y coordinate is positive. So in this second quadrant, x coordinate is always negative and y coordinate is always positive. Okay, in the second quadrant, your x coordinate has to be negative and y coordinate is positive. Now what about in the third quadrant? So what kind of points do we find in the third quadrant? What are the sign of the points? The x coordinate has to be negative, y coordinate has to be negative, right? So every point with negative x coordinate and negative y coordinate, they lies in the third quadrant. Now what about on the fourth quadrant? The x coordinate is, so on the fourth quadrant, so we have x coordinate, so we have positive x coordinate and negative y coordinate, right? So we have positive x coordinate, negative y coordinate. Okay, so first quadrant, so x coordinate, y coordinates has to be positive. Second quadrant, x is negative, y is positive. In the third quadrant, both x and y coordinates, they are negative. In the fourth quadrant, we have x coordinate positive, y coordinate negative. Okay, now if this is the case, now can you tell me in which quadrant we find a point? Okay, we find a point 5, negative 4. So in which quadrant do we find a point 5, negative 4? Fourth quadrant. Okay. Now what about negative 2, 3? Second. Okay. What about 5, 4? Okay. First quadrant. Now what about negative 1, negative 2? Okay. Now what about 6, 0? In which quadrant do we find this point 6, 0? Where do we find a point 6, 0? Okay, it will be on the x-axis. How do you know that? Okay, so here for this point, our y coordinate is 0. Okay, and if you have a point with y coordinate 0, then those points are on the x-axis. Okay, so you have a point, okay, and the y coordinate of that point is 0, then it means the point has to be on the x-axis. Okay, similarly, if you have a point, okay, with the x coordinate 0, let's say we have 0, negative 2. Now this is a point with our x coordinate 0, And if we have a point with a x coordinate 0, then where do we find these points? We find this point on the y-axis. Okay, so every point that we find on the x-axis, okay, so it doesn't matter. So every point that we find on the x-axis, this every point has y coordinate equals to 0. Okay, similarly, every point that we find on the y-axis, every point on the y-axis has x coordinate equals to 0. Okay, so every point on the y coordinate has the x equals to 0, x coordinate equals to 0, and every point on the x-axis has y coordinate or y equals to 0. Okay, so this is about coordinate system. Okay, now here we are not talking about the plotting of points. We have to find the slope of a line. Now we have a slope. Have you heard slope before? Okay, you know how to find the slope, right? Okay, now what does it mean by the slope? So if you are asked to find the slope, what you are calculating? So what does it mean by a slope of a line? What it tells us? So let me give you the slope of a line. Okay, now now let me give you that slope of a line is 2/3. Now what does it mean by that line? What kind of information can we get from this slope 2/3?
So is it going to be quarterly? So it's like 3/2 up, 3/2 up.
Okay. Now what do we understand by the slope? I know you know how to find the slope, right? You all have seen this, right? So you all have seen y2 minus y1 over x2 minus x1, right? You have seen this one. But what does this mean? So what does this slope mean for a line? What it tells us? That's okay. I heard it's steep. Okay. You wanna add something?
No, it's just a statement.
Okay. Anything else? So here, when we talk about when we calculate the slope of a line, means yes, we are just calculating how steep is our line or how inclined our line is. So finding a slope means we are measuring the inclination of our line. Okay. Now our line, it can be horizontal. Okay. We can have a horizontal line. We can have a vertical line. We can have a inclined line. Okay. And so here, finding the slope means we are measuring how inclined this line is. Okay, we are measuring the inclination of a line with respect to the horizontal axis. Okay, that is the slope. Okay, so we use the slope a lot. Okay, even in real life, we use the slope. Like when we are constructing a road on the hills, the road are inclined, right? So we have to measure the slope of that road before we construct. Okay, we can't have a road which is vertically. So can you imagine a road of this kind, like vertically up? So you have seen the road right, which is inclined. It means then there need to be a slope of fixed number. Okay, so we can't just construct with any slope. Okay, so here basically slope means we are measuring the inclination, like how inclined our line is. That's the slope. Okay, now here, so let's consider we have a line. Okay, we have a 2 points. Okay, let's consider we have a points, the first point, and it has a coordinate x1 y1. So we have a point and the coordinate of this point is x1 y1. x1 y1, it is any number. Okay, do not get confused. X1 can be a 2, y1 can be a 3. X1 y1, these are any numbers. Okay, so let's consider we have a point x1 y1. Okay, and we have a second point. So let's say we have a second point here, and the coordinate of second point is x2 y2. So we have the coordinate of second point is x2 y2. So x1 x2, these are the x coordinate, y1 y2 are the y coordinate. Okay, now we have a line joining these 2 points. So we have a line, a non-vertical line joining these 2 points. Okay, one point is x1 y1, other point is x2 y2. Now we measure how inclined is this line is, okay? And to measure the steepness of this line, we use a term slope, okay? So slope help us to know how inclined this line is, okay? And for slope, what do we use? So m is the one that we use to represent slope, okay? M is the slope. We represent our slope by m, okay? And the slope is given by, so we calculate slope by rise over run, okay? So we have a slope. We use m to represent slope, okay? And slope is the rise of a line over run, okay? Now we need to find the rise of a line and the run. Now here, okay, let me add coordinate system here. So I have y-axis, I have x-axis, okay? So this is x-axis, this is y-axis. Okay, just let me write down point over here. So this is x1, y1. Now let's try to find the rise and the run for this line. Okay, now, so let me draw a vertical line from the first point, okay? Let me call this first point is P, second point is Q, okay? And let me draw a vertical line from point Q to the x-axis. So we have this origin here. And the next we draw a vertical line from P to a line QR. So this is QR and we draw a line, horizontal line to a QR. Okay, let me call this is C. This is M. Okay. So we have a point P, point Q. Okay. We draw a vertical line from point P on the x-axis. We draw a vertical line from Q on the x-axis. So QR is the vertical line. Okay. And we draw a horizontal line from P onto a QR line. And we have PC. Now from here, can you tell me what is OM? What is the length of OM equals to? So we have the coordinate of P is x1, y1. So what it means? So what is the meaning of that? The point P, the coordinate of point P is x1, y1. What does that mean? How far is this point from y-axis? How far is point P from y-axis? Can you tell me how far is point P from y-axis? What gives us the distance of a point from y-axis? Is it an x-coordinate or a y-coordinate? What gives us the distance of a point from y-axis? It's the x-coordinate, okay? X-coordinate gives us the distance of a point from y-axis. So this point, okay, so our point P is at a distance x1 from y-axis, okay? So, and that distance, so this distance, okay, from y-axis to a point P, this is our x1, right? So if this distance is x1, then what is this distance equals to? Okay, why is it x1? Are they equal? Okay, now here we can see a rectangle, right? So here we have this rectangle, or like you can, okay, it looks like a square, but we have this rectangle here, and the opposite side of the rectangle is always equal to each other, right? So we have this OM, the distance of OM is x1, okay? Now what about y1? What is this y1 for a point P? What it tells us? So what is y1 for a point P? So that's the distance of a point from x-axis, right? So this distance from x-axis is y1, okay? So this is our y1. X-coordinate give us the distance of a point from y-axis, and the y-coordinate give us the distance of a point from x-axis. Okay, in the similar way, okay, now what about this x2? So what is x2 for us? So what is this x2 for a point Q? What is that x2? So what is x2 for a point Q? What it tells us? x2 is the distance of a point Q from which axis? From y-axis. Okay. So is that distance same as this distance? Do you all agree? Okay. So we can call OR is x2, right? So from O to R we have a distance x2. Okay. Now what about y2? What is this y2 for a point Q? That is the distance of a point Q from x-axis, and which is here QR, right? So this distance QR is our y2. So we have y2. Okay. Now we need to find, can you help me to find the length or distance from M to R? So we know, okay, so what we know? So we know from O to R it is x2, okay, from O to R it is x2, and from O to M it is x1. Then what would be the M to R? So what would be the length from M to R? It would be x2 minus, so from here, so we have, okay, so here from O origin to a point R, this is x2, okay, and the next we have from origin to a point M, that is x1. So we are looking for distance, length of this portion, and this is x2 minus x1. Okay, so we have x2 minus x1. Okay, what can you say about the PM? Okay, so we have PM here. What can you say about the PM and CR? What can we say about these two, PM and CR? Are these equals to each other? Yes, because these are the opposite side of the rectangle. So we have this as a y1. Okay, now let's try to find this distance. We want a distance from Q to C. Okay, let's find the distance, this QC. What will be this distance? So we are trying to find this distance from Q to C. So now here, let's see, what do we know? So we know that from Q to R, this is y2. Okay, from Q to R, this is y2. And we also know from C to R, this is y1. Now what can we say about QC? y2 minus y1. So this is our y2 minus y1. Okay, one more thing. Now we know MR is x2 minus x1. So if MR is x2 minus x1, what is PC? So MR is x2 minus x1. So what is PC equals to? x2 minus x1. They are the opposite side of the rectangle. So this is our x2 minus x1. Okay. Now we focus to our line PQ. Okay, so we have a line PQ here. So this is our line PQ. For this line, okay, rise is, so which one is the rise? So our rise is QC, which is y2 minus y1. Okay, so we have rise equals to y2 minus y1. So our rise is y2 minus y1. And drawn, that is x2 minus x1. So this is our run. Okay, so this line is the run for this line. So which is x2 minus x1. Okay, so our slope M is the slope, and slope is given by rise over run. Rise is y2 minus y1. Run is x2 minus x1. Okay, so we are finding the, so when you are calculating the rise, you are calculating the difference of the y coordinate between 2 points. Okay, and x2 minus x1, that is the difference between x coordinate of a 2 points on the line. Okay, and if we have a 2 points, then we can construct a line and we can find the slope of any line whose, if we know the 2 points of the line, then we can always find the slope. Okay, now let's use this information, okay, this one, to find the slope of a line here. So we are asked to find the slope of a line, okay, passing through a point -1, 2 and -3, 4. So we have a 2 points. We need to find the slope of a line passing through these 2 points. At first, let's draw a line here. So we have a point -1, 2. So let's say we have this point -1, 2, okay, and we have -3, 4. Okay, so we have -3. Let's say we have a point here -3, 4. So these are the 2 points, okay, and through this point a line passes. Okay, so let's draw a straight line that passes through this point. So we have this line. We need to find the slope of this line. Okay, now, okay, it does tell us to plot a point also, okay, and indicate the slope on your plot. Okay, now, so since we are asked to plot a points, we need a coordinate system, right? So let's draw a coordinate system at first. Okay, so let's draw a coordinate system. This is our y-axis, this is our x-axis, so this is our origin. Now, in which quadrant do we find -1, 2 point? So in which quadrant do we find -1, 2 point? Second quadrant, right? Okay, so we go, so in order to plot this point, you go 1 unit, okay, on the left along x-axis. Okay, so we have -1 here, so you go 1 unit left along the x-axis, and your y coordinate is 2. It means we are going 2 unit up, so we go 2 unit up. So we go 2 unit up. Okay, let's say this is 1, this is 2, so this is 1, 2, and we have the final point is this one. So every time you are starting from origin, okay, you go to the horizontal axis along horizontal, then you have to go to along vertical, which is y-axis. Okay, so the coordinate of this point is -1, 2. So this point is -1, 2. Now let's draw -3, 4. So we have -3, 4. So -3 means, so we go, do we go left or right on the horizontal? Left. We have negative means you are going left. Okay, if the x coordinate is negative, you are going left. If the y coordinate is negative, you are going down. Okay, so we go -3. Okay, we go 3 unit on the left. So let's start from origin. Okay, you are starting from origin, you go 3 unit left, so -1, let's say this is -2, -3. So we have -3 here, so you are at this point now, and the y coordinate is 4. Now are we moving up or down? Up. So if it's positive, we are moving up, so we go 4 unit up. So this is 1, 2, 3, 4. Okay, so let's say this is 4. So we have this point as a final point, and the coordinate of this point is -3, 4. Okay, we have a line passing through this point, so let's draw a straight line joining these 2 points here. Okay, I mean, you don't need to show everything here. Okay, you can show a final point. You don't need to show like how you are moving your point. Okay, so if you have a final point, so if you have this point and this point, then it's enough. Okay, you don't need to show everything. Okay, this is the plotting of these 2 points. Now let's find the slope of this point. So we have 2 points. Okay, let me write down those 2 points once again. So we have -1, 2, and we have the second point -3, 4. Okay, now in order to find a slope, let's compare these 2 points with our x1, y1, x2, y2. So first point, let's say this is x1, y1. Second point, let's say this is x2, y2. Or you can switch, it does not matter. Okay, so first point, let's call it x1, y1. Second point, we call it x2, y2. Now we make a comparison. Now if you compare negative 1, 2 with x1, y1, what do we have for x1? So if we compare negative 1, 2 with x1, y1, what do we have for x1? Negative 1. So our x1 is negative 1. Okay. So our x1 is negative 1. What do we have for y1? So 2. Okay. So our x1 is negative 1. Okay. Our y1 is the y coordinate, and the y coordinate of a point is 2. So this is y1. So what about x2? So what is x2 here? x2 is negative 3 and y2 is positive 4. So we know x1 is negative 1, y1 is 2, x2 is negative 3, y2 is 4. Now we substitute these x1, y1, x2, y2 values on our slope. Okay, our slope m, we know slope m is given by rise over run, and rise is y2 minus y1, and the run is x2 minus x1. Now we substitute our x1, y1, x2, y2. Our y2 is 4 minus our y1 is 2 divided by x2. x2 is negative 3. Then we have negative, what is our x1? Negative 1. So we have 4 minus 2, 2 divided, we have negative 3. Negative times negative 1, that is positive 1. Okay, so we have 2 divided negative 3 plus 1, that is negative 2, and we have negative 1. So slope of this line is negative 1. Now what does it mean? Now what is the slope of this line is negative 1? What does it tell us about the line? We know the slope of a line. Now what does it tell us? So here slope of line is negative 1. Okay, so can I write negative 1 as a negative 1 over 1? Is it same thing? So negative 1 is the same as negative 1 over 1, right? Okay, now if we compare this slope with our definition is rise over run, right? So our rise is negative 1, run is positive 1. Now what does it mean by rise is negative 1? It's going down. So as we are moving from left to right, okay, as we are running or like moving from left to right, 1 unit right, okay, as you go 1 unit right, okay, the line is falling down by 1 unit. Okay, so that's the slope. So it tells us whether the line is falling down or line is going up. Okay. Okay, we'll talk more on this one. Okay, let's do this much for today. And those who haven't